Hello everyone, this is a mobile bug detector circuit which is used to detect unwanted use of mobiles in some restricted areas like examination centers, conference halls, patrolments and etc. As we all know that the mobile communication is in the range of 0.9 to 3 GHz range. So here we use a RC tank circuit which is tuned to the frequency which is used in mobile communication. And here we use a two capacitors which is used as voltage divider and a capacitor in between. It is a main capacitor which acts like a loop antenna here, and we connected to that capacitor. And coming to the explanation, as we all know that the mobile communication is in electromagnetic radiation. As per Faraday's law, we know when a conductor is placed in a magnetic field, EMF is induced in the conductor. So when a call is made or message is sent from a mobile, electromagnetic radiation is taken place. So when that electromagnetic radiation strikes the conductor here, EMF is induced in the conductor and it is stored in the capacitor. Here we use a CA3130 op-amp IC, which is a current to voltage converter. The output of the capacitor is connected to both the inverting and non-inverting terminals of the op-amp. To the inverting terminal of the op-amp, we connect a 100 megaohm resistor, which is in the feedback path. So the main reason for connecting the output of the capacitor to both the inputs is to maintain stability, so that it remains the output of the op-amp remains 0 in the initial condition. So whenever the electromagnetic radiation strikes the conductor, the EMF is induced and that EMF is stored in the capacitor. The capacitor supplies minute currents to the op-amp, which converts the current into corresponding voltage. The output of the op-amp is given to a CMOS transistor as well as to a capacitor and a LED. The capacitor here is used to maintain the capacitor here. It is the connected the output of the op-amp. Here the capacitor is used to maintain the base bias voltage for the CMOS transistor, and here we use a LED. The LED is used here just for indication whether the circuit is getting the current or not. So whenever a signal is reached from the op-amp, the signal is given to the CMOS transistor. The CMOS transistor is used here because of high switching speeds. As we all know that whenever the signal comes, it should give the immediate response. So here we use the CMOS transistor, and the output of the CMOS transistor is connected to a 555 timer IC, which is working in the monostable state. Why this 555 is used in the monostable state is because whenever the signal comes, the output should go high, and whenever the signal is not there, the output should be low. So as we all know that in the monostable state, the output has only one stable state. So we uses the monostable state here. So whenever the output of the op-amp is given to the transistor, it goes as a trigger pulse to the 555 timer, and the 555 timer sets to monostable state, giving the high output voltage. The output of the op-amp, the output of the 555 timer IC is connected to the buzzer. So whenever the signal comes, the buzzer keeps on ringing. To avoid the continuous sound of the buzzer, we uses a 15 kilo ohm resistor and a 10 nanofarad capacitor, because to reduce the irritation to the ear. So when coming to the demo of the circuit, whenever we make a call, the circuit should give a buzzer sound. See, I am making a call from my mobile. So as I have called to the number, due to electromagnetic radiation, a signal is received by the conductor and is given to the op-amp. The output of the op-amp goes high, and it is given as the trigger input to the 555 timer IC. So it is going to the monostable state, keeping the buzzer to the high, and the output becomes low when the call is switched off. So in this way, in places like examination centers or else conference halls or in petrol mines, we can reduce the usage of mobile, so that it does not create any disturbance. Thank you.